Well, I guess it seems like I'm a little bit late, but I think I'm just gonna jump out. I'm just a little bit late to when I usually start streaming. Yeah, that's fine. I love you. Yeah, something like that. Alright. Alright, time to stream to absolutely nobody. Woohoo! Alright, so today I'm just going to be... I'm in a testbed application project. Because I'm going to be going over how I want to do my entity component system. I know I've been on this project for like a month or whatever, but I really don't like how the current entity component system works. So I want to redo it and make sure that's all, you know, good to go and all that. So for one, let's do a pragma region forward declarations. Pragma and region. Okay, I'm gonna drop some frames. And let's find out what's going on here. That is just being dumb cool. Alright. Cool. So what kinds of things do we want? Right, we know for a fact that class entity needs to exist. Alright. Now that we have a class component, now that's going to have to exist. Well, let's just do class entity class components class system. Well, we know that these things exist, right? So let's start defining these. System. Right. So the entity classes basically just for the pointer, right? And why is this a thing? Well, the reason why is because we know that hold on, come on. Don't do this to me. Right, we know that an entity is just an ID, right? And this being said, we know that pointers are unique. Pointers are IDs, right? And there's a one-to-one mapping between objects and pointers, right? So that's why we want the entity. So basically what we're going to be doing is just passing around the pointer all over the place, right? So now we know that the component is going to have some kind of, you know, arrays of data goes here, right? And each one will have its own things, right? But these arrays need to be very specialized, right? So let's do C. Well, let's do an interface of C array. iCar and then class K array. let's start defining these, shall we? Oh, except these are probably going to need to be defined and done up here. So class I car is here, and then here we can do class car extends public car. Right. So we know that these are going to be, oh, this is going to be a template, and I'll show you why. Right. Because we want to have some kind of array, right? And the array may be private. Right, the array itself can be private. And then this is going to be T data array. Now, as much as I would like to, because like I am going to be doing some things like mem copy and things like that. And why do I have a little bump on my thingy? Mem copy. Let's go to Geeks for Geeks. Copies the specific number of bytes from one memory location to the other memory location regardless of the type stored. Okay, so I could do a lot of mem copy stuff. Yeah, I need to do that. There, cool. So I do the 4 declarations here so that I can make sure that, you know, whatever's happening, basically so that things understand that things exist before they're actually, you know, created and stuff like that. Which is kind of an important thing to do. Right. And the iCar is important for later casting and holding information and things like that. So we can have something along the lines of, like, say, in component, right? We can have something along the lines of like K array of type std string text. Right, we can have something along these lines, right? Which is kind of an important feature. So I can do 1024 just for now. Right. And the whole point here is that we will have now the K array is going to have 2 very specific things, right? Because we know that we're going to have a push, because it's effectively like a type of stack, right? Where you know, when you have, you know, buckets, right? And then you have, you know, like 1, 3, 4, you know, right? And then you would push onto it, and then you can pull, here, right? You can do that, right? So that's the basic thing. So we know that we need to have a void push, and then this t data, push t dat, and then we can have a t or return t, and this is pull, right? And this is int index. Right. We know for a fact that we have these two, and since these two are effectively templated, I need to define these in here. Right. So what happens when you push? Well, another thing that we need to know about is that size t, size t head. Right. And then when we push, we want to be able to say that you know, data at index head plus plus is equal to data. Right. Let's say val. Right. Val. God damn it. Right. Cool. And then here, what we can say is we have a t. Val is equal to data at index minus what is it at index, right? And then data at index is equal to data at minus head, and then you return the value. That's literally what it's doing. I know this seems like magic, some Carmackian excuses of abuse of syntax, but trust me, it'll work. It works just fine. Okay, so we also want to have a size t, let's say count, well, I mean, I can, oh well, it's all gonna be kind of whatever. Since it is a template, it would just be better to do it this way anyway, so I'm just gonna do that. Return head. This way we can tell how many objects are in there. I think that's just about it for this for now. And the, you know, compressed array. Right. Now, I think in all actuality, a big part of this would be that you'd have, you know, capacity as well. And once the head reaches the capacity, it would end up increasing however much is there. Right? And then you do a mem copy, a memory copy. I think 1024 for now is perfect, is just fine for just testing. Right? Okay. So for the most part, we just care about the pointer. Oh, and this is also going to be a static, you know, static k array, cd string text, right? Here, We'll also have a thing where we have, you know, something along the lines of, say, void pointer prints. Well, this would be it's an inline static void print equals right. There's that. You can say cout, well, std cout printing cd and L. And we can do this for now. Or something along these lines, but really in reality, be doing things a little bit differently, right? So. Now, being able to sweep through all of the components all at once, all of the data of all the components all at once, and then doing everything is a little bit unrealistic. It's a lot more likely that you'd have something along the lines of just you'd have like different stuff, right? So because in essence you'd have like the print system being able to, well, I mean, you're not really going to be seeing a lot of these systems, right? So it might be better to have an array or a set, maybe even like a set that has like a system, like you might have like a set that'll have a function pointer and a signature, right? So what you can do is say you'd have public, let's say on init. Oh wait, what would it be? Be an std set, or it can be either a set or because I might be able to do static std set of std pair of type we could do like an std pair, and then we'd have a void pointer int, something along these lines, or it would be a set of pairs. But do I really like this? That's the thing. Because I don't know if I like this. And this would be on init equals static inline. Does inline need to be first? I think inline static equals yeah, you can do this, right? You can do You know, we can do something along these lines. TD hair. How was I doing? I have no idea. Oh, well, that's actually kind of sort of doing it. Let's see. I mean, I guess I could do other things, like have a Geeks for Geeks static hair, but yeah, it will be first and then second. I'm not entirely super pleased with that kind of thing, right? Because that seems just a little bit messy to me, so it might be a little bit better. Just have something along the lines of, say, have a different public set. Let's just delete that, and then maybe struct. One of the things that we could do is say something along the lines of, so what we want to do is have a signature, so we also need to have a signature. And the signature is a bit field. Is it a C++ bit field? Because you'd be struct data. Alright, cool. 3 bits, 6 bits, 5 bits, 8 bits. Yeah, struct data. So I don't can do that. What? This is not what I want. Let's go back to system. There we go. Let's go here. See exactly what he used. Let's take a look at signature. Bit set. Alright, so we can have C++ bit set. And then Geeks for Geeks, because I like Geeks for Geeks. Geeks for Geeks is just better. Bit set size, variable name, initialization. Okay, so you can have bit sets. I think bit sets is going to be. Yeah, so I can have a bit set. Struct. Sysstruct. And then here we'll have a void. And then this is fn. Alright, we're gonna have that in void fn, and then here we can have an std bit set, I need to have actual bit sets hash include bit set. And then here we can have, say, let's do 32. Should be plenty for now. Set 32 is signature, right? We can have this for now, right? Sys, right? So here we can have a sys struct, and then here what we can have is we want to have on init, right? We have the on init is a thing. And what kind of thing is it? It'll be a yeah, but what is it going to be? Let's just say that it is this struct on init. And this could be inline static. Here. Yeah. Empty initializer is invalid for okay. Right here. And then we can do this, right? So we can have alright, this be here. And then, effectively, what we do is we can have, say, and then this can be oh. Let's do an auto for. Let's take a look at C++. 204. For range space, but I don't want range space. I want for auto. Okay. That's real. For auto, blah blah blah, and blah 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 blah. But there's nothing in here. Whee. Okay, for auto key value, Indo. Okay. Okay. Because there's nothing in here. There's bloody nothing. There's nothing in there. Okay. What's this? Yeah. Well, everything should compile. It should be fine. So we can do int test. And then we can say for 1723. Right. And then you can say for auto let's see here, for auto val and test TD C out. Well, T and L. And then hopefully nothing breaks. It should compile just fine. I'm not doing anything crazy, so it should be perfectly safe. Cool. Okay, so that does work. So it does work like that, so I can be lazy, which is good. I like being able to be lazy. It's nice being able to be lazy. Which means that it would be struct, and this would be the print. So I can do DC out, and then this will be TD and down. Right. Okay. So it'll do all the on init stuff. Cool. And effectively what will happen is run on init. Right, the on init systems, it's effectively just an event. But I might not actually implement events in order to run it. I might later on, but I'm not really too terribly concerned about it at the moment. So well, in all actuality, the signatures are going to need to be a thing, which means that the bit sets will also be a thing. And then, oh yeah, and then I also need a set 32, let's say 15. Right? Cool. So now this way it'll have its own stuff. And there's other things to keep in mind with all this, right? There's like different ways of using bit sets and initializing them and things like that, right? So let's take a look at what's going on. Come on. Yeah. On bitset and its applications. Bitset variable name binary. Bitset variable name string. Binary string. String binary string. That's really nice. Okay. Reset, set and reset, flip. Count. Use boolean value at the given index. Okay. So there's a bunch of things that I could do. There are different ways of handling it, so that's fine. Bitwise and, bitwise or, bitwise XOR, and things like that. Okay, so I can do a lot of really nifty tests with it. I'm not too terribly worried about it at the moment. But that should be fine. So I just want to be able to have text. Alright, and get text working. Which means in all actuality, what I really should have is a class. Do I want it have to be a class, or should I do like a hash define or something along those lines, like a using or something like that? Let's take a look at C++, entity component system. Take a look at how it's implemented here, what signature is, right? Because component type signature is a bit set max components, simple alias, the using signature equals do. That's fine, which means that I can have the signature do the things that needs to happen, right? So I can have the signature be like a certain way. And how are the components going to engage with the entities? Because the entities are going to need to have do I really want to do like all the registration stuff? So I feel like that's a little bit excessive. I mean, it's all going to be just in memory regardless, I feel like. Yeah. Be inheriting something here. Void physics system update. Okay. So how do I actually want to do this, right? Because we know that the components are going to be, right, because we have a static thing here, and we also need to have like a thing. And the components can have one kind of thing, but it could also have different other forms of stuff too. Like it can have a struct that is a vector and it can do things, but I think for the most part what I would like to do is I have one viewer. Say hi in chat if you are here. And let me know if you can hear me well enough. I mean, I should be pretty audible, I feel like. Okay, so I could have the bit set be a thing, or I could have a using declaration up in here, so I can have using signature equals std bit set 64. Right, cool. And then in here, the struct system will be signature sig, right? So that'll be that. And then it'll be signature 15. Right, so I can do something along those lines, or I can even have, say, 2 3 4 1 2 3 4. Right, I can do that. Or I can just say, you know, 1. That's fine. So the on inits, or I can just say inits equals this, and the signature is 1. And then you can also do things like say print system. Right? And then how would it actually work, right? So you would have to go through like all of the stuff, because the system struct, because each system is also going to have like some kind of, like I could have a set. I mean, I could have a set of pointers, of entity pointers. Right? Because like the pointers aren't that big of a deal. Right? Because like the biggest thing about the other entity component system that I was doing is that an entity was just a number, so it could be just completely pre-compiled and pre-computed and all that, which is really cool, really nice. But for the most part, it was kind of a colossal pain in the neck to work with. So like the actual system manager itself, you'd have like registering the systems and all this other stuff that I really don't like. And then you'd have to let the system know that it was being destroyed and all this other stuff, and I don't really like all that stuff, so you'd have to have like all the different signatures and all these other things too. But I'm not like super pleased with all that, because I like to have like a signature that is just you set it to the stuff that you want, right? And like it is left-handed, so it shouldn't be that big of a deal, you know, like I can do that. But like 1 works as well, so it's fine. But it would also be pretty nice to be able to just say, hey, components, get, you know, whatever text is, things like that. So, the only real way of doing that is kind of by hand, right? So, like, what's actually going on? Because each of the indices need to be able to do this stuff. Because I'd really want to be able to do something along the lines of, say, entity E. And here it is, entity E. Right. Well, and this is also, yeah, this should be on init. Or init list. Yeah, init list is this. So all of these are all of the systems that are dependent on, well, these are the systems that are a part of the init thing, right? Because in here we have inline static void inits, or like on init, like static void on init, and then in here would have for, oh, but this is interesting. Well, I mean, one way of doing it is that I could say int I equals 0 for auto sys in init list. Right, I can do something along these lines. Right, this is the sysstruct, right? So it is, you know, I just do because you do need to update which ones are changed. And I also don't really know how many different like entities are going to be involved and stuff like that, because it is like entity pointers. Right? I'm not doing the actual entities, I'm doing like an entity pointer. And here it's a pointer to an entity. You know, and here it's the component, you know, component get text. And then gonna be now component text E. You know, and then in here I have public static, you know, inline static get, and then we have a car component, and then it would be a entity pointer E, right? Static void get. Well, I mean, ooh, but this is a little bit strange, right? It's technically void, which means that this needs to be so I need to find out what kind of thing it is, and it'd be nice to just be able to say type of. Alright. Which is why that whole thing did the thing. Because otherwise I'd have to tell it like what type it is. But I feel like that's not necessarily a terribly bad thing. Alright, so let's just do it that way. And T. And this is a car array of T comp. Right, and instead of void, this is a T. Alright. And then in here, basically what it's doing is that it's going to have to take into consideration, right, whatever the component is. You know, component text, and these the get, and then this is, you know, std string. Wait, but do I even need it? Because it's like not mad at me for doing that. Can I just do that? Oh, it's automatic! Oh, that's so cool! Oh, I love this! Oh, that makes things so nice. This is 40 kilobytes of stack. Okay, that's what I thought. I might just have this be a reference instead of actually putting that much onto the stack. Like that's dumb. Oh yeah, because it'd be all by you. Yeah, that needs to be a reference. Okay, that's good to know. Yeah, 40 kilobytes. That's excessive. So how's this gonna go? Okay, so how's this gonna go? So we have the component, we get the component, and we get the entity, which means that we need to be able to return whatever the entry is, which means that we also need to have a static. Well, I mean, it might be a little bit better to be able to say, instead of doing something like that, it might be better to have something along the lines of struct component struct. Right, we can have something along these lines, which means that instead of the car way comp, what we can have is actually the. I mean, and this also should be. Yeah, this should also be templated. Template type name T struct, and then in here we actually have is the component struct here. Get component struct. Event list for class template. Yeah. T comp. And then this should be so cool. Okay, so here we go, right? So we have is a K array of type T data. And we also have to have a map of entity pointers to indices. Right, so whenever we Yeah, because we need to be able to have. Okay, we at least need to have std unordered map of type entity pointers and size t. And then this is indices. And this is the indices. Which means that when we get a component, alright, we can kind of remove that for now, but it's fine. Because in here what we'll have is component struct. Well, I mean, it'll be inline static component struct of type std string text, and then this will be oh. I actually don't need to. I think I can just do this. I should be able to do this. Which means it's text. Yeah, okay. Come on, start 10. This is the entities, the size entities, and then get. Alright, and then when you get a component, set and component, what you do is you want to return whatever is in the comp.data at the entry of E. Right? And this is assuming E is in the component list. Right. Which means it should be fine. Now, this could fail, right? Let's take a look at the component manager, see what happens. So, get component, return component array, get data entity. An array for an entity, get data entity. Right, and we also have a bunch of like shared components and things like that. I'm getting the component array and all this other stuff here. And component types and component arrays, but the components aren't the ones who are actually managing all that. It's actually the systems. Wait, hold on. Where's the whole is that in the entity? Oh wait, no, this is in component array. So the component array has all that stuff, which means that when you want to get the data, assert find entity retrieving non-existent components. Find entity and then that to the end. Okay. Means I will have to Assuming the entity is in the component list, right? Or I guess it's in the component array. That's fine. And so we have the indices, right? Get the so now what we need to do is have, this is really cool. Component get component text e. I mean, it is technically possible to have, it is possible to override operator for something like component text at entity, right? Component text E, which is a little bit different because you would expect something along the lines instead of something like e.text, something like e.text or something along those lines, right? It is a little bit backwards from how a lot of people like to do things. I might actually do that, right? Because instead of having to get, you know, I'd want to have a getter and setter and things like that. You know, because it would be kind of nice to have a few overrides and things along these lines. You know, I'm going to do that because I don't like how this works. What I'd rather have is components text at E. Yeah, component text E, right? And then I'm actually just gonna capitalize this because I think that just makes a little bit more sense to me. Right? So there is no overload for this. No operator blah 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 exists, right? So how do I fix this? Well, in order to fix that, I need to go into, because this is a component struct, right? So struct component struct, and then we can have how do I overload? C++ overloading operator. Okay, let's go. Because I feel like having some semblance of object-oriented programming is something that's really, really important. So how do I overload it? Writer overloading. Int reference operator bloop. Okay. So I am going to have to do something along the lines of, say, T reference, and then this is operator of that, and then it is the T E, right? And then what we are doing here, you know, and all this is templated, so I am going to have to actually define it in here. So effectively what I'm doing is that I need to be able to return data at indices at E. Right? Return data indices at E. Yeah, this should work marvelously. Because this actually makes kind of sense. This kind of sort of makes sense. Which is brilliant. I love how this is working. Right. So, I mean, do I really care about the signatures? Well, yeah, I do care about the signatures, because the signatures are going to be... Because, I mean, here, I can also do a public, and then it'll be a signature sig here, right? And then the entities will be in charge of the signatures, which is also absolutely brilliant. It's so simple. It's so nice. Because then I can just have the I car and the K array. I can just have the K array, and I might not even need to have the public I car. We'll see if it comes up, but it might not. It might be completely unnecessary to have it be of a certain type. It might be completely unnecessary to have this inheritance property, because I just have the push and the pull, and that's fine. And I can also even have the T reference operator, and then here I can have an int, right? Int I. Well, operator this, and then this is int I. And in here I can also return data at index I. Right? And this is fine, right? This is really cool. So I can push and pull and I can index into it just fine. Which, super nice. Yeah, because I also need to be able to do that. Data at indices, yeah, this is perfect. So I have the signature here, so an entity is just a signature. It's mostly just for the pointer. Just a pointer to a signature, but I also want to have this inheritance. The inheritance is super important. I can just remove that, because that's a thing I'm already doing. Oh, this is so good. I'm so happy about how this is all turning out. Okay, so now the systems. Now exactly how are the systems going to have, right? So I want the on init to go for auto sys. In the int list, I want to make sure that wait for auto system in it. I want to go through every system. I want to go through every system's Alright. And init list struct. I don't want to necessarily go through every single thing, because I just have the void, I have the void pointers and TE. Ooh. Actually, this needs to be changed. Instead of a system struct, it is an init struct. Init struct. This is an init struct. Because, we have, because you have init update close, things like that. So, because we'll also have like a struct that has, you know, the update, which will have a different function pointer signature. Yeah, I still technically have one viewer, allegedly. Okay, so what are the different things that I need, right? Because on a init, I need to go through every single system in the init list. Right? I can do a for auto entity in sys.entities. Right? I can do this, which means that I need to add that in. And do I want to have like, I mean, the order in which the entities are done doesn't really matter. I want to be able to quickly and easily add and remove things. So I can do an std set of type to t pointers entities, right? I want to be able to do that, right? For auto entities, right? And then what I can do, sys entities, and then the entity list, sys sig. Well, I mean, I can do system. No, wait, no, I don't want to do that. Add a sys function. Sysfn, sys function, the system function, something along these lines, something like that, right? No, the system function, the signature, and then the rest of it should be fine, right? Because it'll just make it if it's not present, I do believe. As long as everything's in the correct order, and it'll be fine. Reach entity, not an entity. Oh, that's so cool. So I can do sys function int proto. God, this is so beautiful. Right, and this should work. I feel like it should kind of work as is. Now all I need to do is be able to have a way to add. I need to have. I don't understand why that's all collapsing weird, but you know, whatever. I don't like that. It shouldn't be collapsing here, it should be collapsing here. But, you know, I mean, it is what it is. Okay, let's do plus operator. C++. Overloading. Operator overloading in C++. Let's take a look at that. I like using Geeks for Geeks because it's really good information. It's reliable and other things like that. Complex operator, complex const object. Alright. But what about, say, public complex real imaginary, operator plus, complex 1, complex 2. That's okay, and it returns a thing, right? So I might be able to do void. I might be able to do void operator plus, and then this will be entity. Do I want E plus the component? Yeah, I mean I could do that. Right. No, E, and then component struct comp. And then I can do that. Too many parameters for this operator. Instantiation of class, blah blah blah, with do. Component struct T comp. Particular instantiation of class. Struct. Too many parameters for this operator function detected during instantiation of class Y. Yeah, I don't understand that. Should be able to do void. Do I just need to do that? Huh? Okay. Wait. Complex operator. Complex. Global operator function is made friend of this class so that it can access private members. Interesting. C++ plus operator overloading. Types. Let's say operator overloading. Let's just do C++. Okay, that's Quora. Return temp class name. In the case of a non-static member function, the binary operator with one argument. One class member object should be public if operator overloading is implemented. Operators that cannot be overloaded are blah 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 blah. Declaring that function as friend functions are blah 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 blah. Operator function must be either a non-static member or a friend function. Okay. The mirror operator function no argument should be passed. It works only when you class object. Operator. Feet inch out. Okay. Binary operators. Distance, feet inches, doing things, and then operator distance d2. Okay, call by reference. Okay, so it is the pointer, and then what happens is that's still doing funky wonky things, so that's fine. Yeah, I understand why that's doing the thing. Okay, so this is not actually doing much of anything, which means... Oh, but what I do want to do is return. Ooh, because what I can do is I can do a T reference, and then what I can do is return. Well, for one, what I want to do is say I want to add indices. Well, for one, what I want to do is say private count, right, is is equal to the count and then push nothing. I mean, that's kind of interesting, right? Let's take a look here, right? Alright, because one thing that I can do is I can say player plus component text equals, you know, this is some text, right? You know, like, that's a thing that you can do. Player plus component text. Like, that would be really nice to be able to do. Right, because otherwise you'd have otherwise it'd be components add, and then it'd be player, and that'd be player components text, and then it would be something along the lines of, you know, this is some text, right? Otherwise it'd be something like this, right? And this seems really weird to me. Like, it makes sense. Like, I guess it's fine, because you'd also just have that, you know, or just, you know, this. Otherwise it'd be this, you know. In a constructor, you know, it'd be like that. I think this seems a little bit more readable to me, because you're doing this plus component text equals. Which means that you would have, I mean, I'm just gonna kind of go for it and see what happens, you know. I mean, what's the worst that can happen? Which means that size t index is equal to data dot count, and then you would say indices at e is equal to index, right, and then data dot push, nothing, This one does that, and then you do return data at index. Data at index, right? Yeah, that should be fine, right? And the signatures. The signatures are the things that are really going to be messy. Because whenever you do that, you're going to have to update the update the system, update the signatures, right? Because you're also going to have to figure out whatever these things are, right? That does make things a little bit more complicated. Because each of these components, like every component occupies some space in the signatures. They occupy a bit in the signature. So again, do we even really need the signatures? Because like the components operate that. Do I need signatures? The only other thing that I could do is just say, hey, alright, I also want to have the operator minus, so I can subtract an entity, and then that will be called whenever you delete an entity. Alright. And a lot of this is just like if, E isn't even in the indices, you want to just return nothing. Or throw an error or something. What was I doing again? Updating the signatures, because we need to let everyone know that the signature had changed. Including the entity needs to know that its signature has changed. Alright. I mean, the structs could have their own thing. So, where is Smart Geeks for Geek stuff? C++. Do. Where's all the signature stuff? Alright, so let's take a look at the signatures. The signature bit set. Push entities. Living entity count. Return ID. Available entities fronts. Bunch of crazy crap here. Insert. Push. And signature, set signature, gold signature, M signatures entity. So there's just a list of signatures. That's cool, I guess. It's an array of signatures for some reason. I don't understand that at all. Okay, and then here, what's going on here? What's going on here? So how do the components change? Index entities and entities to index map, that's fine. Then you remove the data and you do all that stuff. Get component type, add component, insert data. But whenever you insert the data, you also have to update the signatures, right? Why is there no signature stuff though? Why no signatures there? Wait, when does... I saw the component stuff. The component stuff isn't setting any signatures. Huh. Set the signature for this system. So you'd have to do all that, and then whenever you set it, you erase that and your signature changed. Wait, but when does the... Get signature... Okay, so in the coordinator is the one that sets all the signatures. Right, the component manager, add component, and entity manager set signature entity. Signature set component manager get component type T is true. So whenever... What the hell? And then this is your... It's a system manager component, so whenever you set signature, empty signature, and signature set component manager, get component type T. True. Interesting. So the other way around this, the entity has the signature. Whenever you add a component to an entity, you also need to update its signature. How do you find out what bit your... I mean, like, one way of doing it, it's like one way of doing it is, it's like the only other way of doing it right, because you could do something along the lines of the enum IDs. You know, you can have count, you can have text, you can have that, and then the text is the first one. You can go all the way through, and then you can have the text be in whatever order you want. You would update the enum IDs, but I don't really like that. It seems very messy. Right, and this is why you would register all the components, because as you register the components, you would be incrementing what their IDs are. Right. Well, the other way of doing it. So you can also have an ID number in it. And just as you make them, you know, you'd have a component struct text, string text, and then that would be the component struct. You can also have like a size T ID. You have that, right? So then in here you could say 1. And that'll be fine. And the next one would be 2, and the next one would be 3, 4, 5, etc. That's fine. I don't super enjoy that. I feel like it could be very prone to, like, I feel like it could be very prone to errors and things like that. Different clashes and things along these lines. But I feel like it should be fine, perhaps. Size TID. I feel like it'd be okay. Because effectively what you do is you set the signature to be... And when you set signature, what happens? You do destroy set signature. It's a system feature set signature. Get component, remove component, add component, type, restrict components, component manager, component array, and then the entity set signature. Assert end signature entities equals signature. But that's not what we wanted. What we want is to be able to... There's so much going on. Yeah, signature set. E.signature set. And that's the component manager. And you get a component type T. True. So that is something that you could do. I could do that. Means index index return index, right? Indices A. Return data, data push. Nothing. And then you can also say E sig dot set, and that would be ID true, right? And I could also do T a T reference operator minus and to T. This is a lot of different things. So size T index equals data dot count minus 1. Oh, well. Oh, actually, size T index is equal to disease at E, right? Because we want to be able to pull, right? Because this is something along the lines of, you know, player minus component text, right? Player minus component text, right? Technically speaking, you know, because I could go blank std string last text is equal to the player minus component text, right? Because you're returning a reference to it, or at least the value of it and stuff like that. It should be fine, right? Because as soon as it's done and over with, it just gets destroyed, and it's okay and over with. C++ is very weird. There's a lot of things going on. I have tested some of this stuff off camera. So we have size t index equals this is e. Then we do data dot pull index. Oh, I could do t value equal to index, and then we also want to say e.sig dot set. We do false, right? And then update the signature. And we also will need to also say what is it? Broadcast signature change. And here we would broadcast signature change here, right? And then yeah, we say val t val equals that and return data index. Okay, t val data pull index. I mean, I could just return pull index. Because I don't really need to have any of that. Don't need that there. Since set index equals indices e. I mean, I could just do data dot count. Oh wait. Because index isn't used anymore. So that is nice. So I can do that. I can do sig set e. And then I can also do data dot pull. And I can really just do return data dot pull at this is e. Alright, yeah, that should be fine. Return data index. CZE. Index is used multiple times, but it's fine. Data count, data push. Let's return data indices. Yeah, it should be fine because this is a reference to it, which means that I can change it. This is also a reference to that, which means that I can get information from it. And I shouldn't be able to change it because as soon as it's done, it's destroyed effectively. Which means I also need to. Yeah, okay. Because I don't like any of that stuff. So we have all that sys function. That's the sys function. Entity. Okay, cool. So what are we gonna do here? It's a component entity. Entity is still tiny as always, which is great. Inheritance? Question mark? Because I might not need any need for. I might not have any need for inheritance. And yes, this is an overly simplified entity component system, and it should work. And to be honest with you, I'm okay with the simplicity. I very much like very simple, simple systems. I would like things to be very compact and very simple. I don't like a massive level of overhead. I don't like the overhead. It complicates things too much. I mean, I might be too smooth-brained to figure it all out, but I'm just trying to make games, so I want to have a system that is easy for me to work with. And I feel like it's just, you know, kind of common sense to, you know, have these things in place. So, because I don't want I don't want to have a horrendously complicated engine, because I don't want to have to deal with it. If there's any bugs or anything like that, then it's going to be an absolute nightmare for me to sift through an incredibly highly sophisticated and complex system. It's going to be too much for me to go through, because if I'm making a game, then I have to figure out, oh, well, is it, you know, what is the problem, you know? Yeah. Is there a way to just kind of... I feel like there is. I feel like there's a way to say in C++. I should probably keep that one open. C++, iterate through a classes members. Right through structuring class members, okay. Is it possible to iterate through iterating over a struct C++? A. That's struct A. For each and every member of the structure and point its value, something like blah 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 for each member of struct A. See out struct name, member name, value. It's fun in C++. Perhaps you can string something together using boost fusion funnets. I don't like that. Without boost, you can't iterate over an object's members. You can use stream insertion operator to print individually, however. That's fine. There are a couple ways to do this. We need to use some macros to either define or adapt the struct. Reflectable macro given this error. So we define a struct like this, reflectable into blah and const char blah. And then you can iterate over the fields and print each value like this. Class field data void operator field data f say out f.in f.get. That's a lot of crap that I don't want to deal with. Boost fusion, adapt fusion sequences. Oof. There are macros which will, behind the scenes, save them into a collection of some sort on which you can iterate. Provide method for accomplishing what you're asking for. You iterate on so the container you cannot iterate over again. There's a certain type. Reflection as this type of feature is most often referred to as in part of C++. Charles struct. John's code. Get and your tuple and use self. Yeah, I really don't. Again, return pointer s type name. Yes, return. Ads, I don't like that. Okay. Oh, this is a lot. Cool, good to know. You can't really do that, which is fine. Because there are other ways. But I feel like there is a way to have all this go through so you can like initialize the components. And then in that it would go through all the components that you have and, you know, do things. But I feel like that's, again, a bunch of sophistication that I don't actually care about. Alright, do I have any viewers? I still have one. Cool. I have a silent lurker in my chat. Allegedly. Do I have any more Pepsi? Da, 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 da. 149. Okay. Still got 2 more hours. So I have the init struct, which happens all of that, so the on init, cool. The init list, that's fine. Text. Because otherwise I would have to have a base component struct. And here it would be I could do an array and then do a for each. And then populate things like that. I mean, that also seems a little bit excessive too. Because otherwise I'd have to, you know, anytime that you would add or subtract, you'd have to iterate through every single, you know, component. And you also wouldn't be able to have names associated with it. It just seems like it'd be too much of a pain in the ass. I feel like it'd be too hard to work with. So I'm not going to do it that way. I would be, I'd be moving the headache around. I'd rather the headache be here than anywhere else, honestly. Because otherwise I'd have to have like an enum, and the enum would have the ordering of everything, and I don't really care enough for that. So I'm not going to do that. So what next do we have? We have the signatures, and we need to be able to figure out what the signatures are. Right. Because the only other way of doing it, right, is you'd have a I mean, that's a little bit. Oh, well, I mean, one thing you could do is say, text.id And then you could also do and. Oh, that's so much. Oh, that is so much. I feel like in order to do that, you would have to have like the signature, and the signature could be a property. It could be a read-only property. So I could do that. I can have a read-only property. How does this work? 'Cause I would like this to be a property. TN, and then I think you would have the. Yeah, it's the type and then the name. Okay. So the type is going to be a size T, and then the name is sig. Is the signature, right? Right, and then what you can do is you can say get sig is equal to yeah, it's fine. Not a type name detected. Remember, dsig is not a type name detected, but it should be fine, I think. Return one moved over by ID. Yeah, I think as a property this is kind of bad. So I can just do inline. Oh wait, but it's not necessary. Yeah, I can just do get signature and the size T, get signature, return one moved over by ID. That's fine. I don't really care all that much. Because then down here I can say get sig. Right. Because the signature is the get signature, and then you can compound on top of it. Right, because you can also say and. You know, I mean, you can say components text dot get signature, right? And you can also do and component dot whatever dot get sig, right? So that's fine. Yeah. So that way it'd be a lot easier to figure out. Okay, cool. So why actually do we want to do this, right? So one thing we could do here is we have the on init, and this is done. This stuff seems to be just about done. The init struct is just about done. The systems will need to have some kind of Right, well, I mean, you need to be able to update the entities. So you're gonna have to go through each of the init lists, the update lists, all these different systems that have, you know, all the different things going on. Right. I'm sure there's like other ways of doing things, so you can like load in your own systems and things along those lines. You know, by doing like some mem copy and a bunch of other stuff to add in your own systems, but I'm not too worried about that yet. Because I feel like for a lot of this, I'm just going to be doing, like, for me personally, I'm not going to be doing a lot of custom stuff, and the community is always going to be smarter than me anyway, so I don't really care all that much. So I don't really care. Get signature is fine. This operator is fine. This operator is fine. This operator's doing its own thing, I guess. So I need to be able to tell that I need to be able to tell that the system has, you know, updated, right? That a signature has changed somewhere. That an entity signature has changed. The entity's just a signature. Right? And again, I do want inheritance for the entity class. And the K array, I don't know if I need the inheritance for the K array. I might not need the inheritance for that. Signature is just a bit set, so that's fine. I don't need that to be a class. The component needs to be able to tell the systems that the I mean, there's like a few different ways of doing it, right? Because not every system is going to have... Yeah, but realistically, how many systems are going to be even in a game? Like in an engine? And how often is it going to be pulled, right? So, one of the things that I want to do is have an inline static void signature changed, and this is an entity pointer E and signature reference S. Right. I mean, I don't really need to do all this like this, but I feel like it should be fine. Like, there are some potential issues with a lot of these things. But I'm just gonna do it all in the header file anyway, because you can. Okay, so the signature changed. It's what happens when the signature changes. Right. So here it would be system signature changed, and then it is E. Oh, I actually only need just the entity. I don't need to have the signature. Because the entity contains its own signature. Right? So, first of all, oh, wait. E. Wait, if signature E. How do I check to see? Get component shared system. Let's take a look at what happens when a coordinator entity signature change for constant pair in systems type pair first. System signature type. If entity signature and system signature equals system signature, then so if entity signature and sig equals sig, oh, what I want to do is for auto reference system in init list. So if the E sig and system.sig equals system.sig, then I need to add it to the set. I need to add the signature to the set. System dot entities dot insert E else system dot entities dot erase E. Cool. Yeah. Entities insert entity, system entities erase entity. Right? Yeah, that should be it. And prove that, so that just it's fine, right? We'll go through every single system, all of them. Alright. Now we'll have to do this for the init list, the update list, and all that as well. Yeah, I'll just do that. Okay. So that should be fun. So the idea is, you know, this is not super great, but it should be fine. And there are plenty of reasons why the, you know, like the bit set and all this other stuff is not good, but it should be fine. I mean, technically speaking, on it. Just a second. Yeah, all these are sending in pointers everywhere. I didn't even need a black box. Does this system have its own? Is this really it? I feel like it can't be this easy. Like, it's only been 2 hours and I already have like basically everything. I have a bunch of crap that's not even necessary. Well, I mean, I guess let's find out. Entity, testicles, entity. Oh, I should just make that this, and then I should just make this new entity, right? And then I could do test plus component text equals test is equal to, this is the test text. Okay, so it'd be component text plus test. And then system init should be it, right? I mean, that should be it. Oh, I have a failed system. What failed? Possible lost data, that's fine. Push function does not take 0 arguments. Ooh. So in here, so the push function does not take 0 arguments. That's an easy fix. I can just say void push. This is data. Oh, head plus plus. That should be it. I mean, there's a bunch of errors and warnings at least. I think it worked. Oh, this is lovely. I think this is way better than the way that it was working before. I mean, and I do like the idea that you can just have things do things. You know, I mean, this isn't nearly as sophisticated as a lot of different ways I need to do it, but like as a proof of concept, I mean, this is fine. Because like, let's do like an inline static component struct int 2. You know, I could do this, and it'll just work. You know, because I can do init structs. I can just have this init struct here. It's fine. You know, do that. Struct. You know, I can have the init struct here. Do, you know, oh yeah. Right, so I can have that here, right? And here I can also just do, say, std cout components integer d and oh. Signature. No, I don't like how this is doing all this crap, but it's fine. Integer. Get sick. Right. And I can do init struct. I'm just gonna go for it. And I'm just gonna do td cout text. And this is components text components text at e, and here std and l. Signature. Oh wait, I'm gonna do std cout integer. Integer at e. Std and l. I think I have an even simpler. This is like the simplest bloody one that you could possibly get. Components text.getSig, and component I need to figure out what the hell is going on here. What the bloody hell? I hope I didn't just get screwed over hardcore. That was frustrating. I don't know what's going on there. Okay. Cool, I think that's about where it needs to be. Hopefully. Yeah, I don't know what's going on there. Alright, and teacher.getSig. Cool. So these things are perfect, right? So why? Right? Because here I can say right, because here get this out, right? Well, I can say class test1. Here it's public entity, right? So it becomes a type of entity, right? And this is here test1. Right here it is so component text plus this equals, here is the tester, right? Could have that, right? txt entity txt entity, yeah, text entity. Cool, we have one of those, right? We can do a class, and we can have int entity public entity. Right, and we can have, well, I mean, this needs to be public. And then this needs to be public. No, wait, no, yeah, that's public, so it is inheriting it because it's public. So it should be fine. T. Integer plus this equals 5. Right? Cool. Oh, I love this. And you can also do other things too, because you can also have, say, you know, you can do all kinds of things, right? Class, oh, what's going on here? Come on. You're actually gonna work? Gonna work here, bud? You gonna work here, bud? Okay. That's good. And I can probably afford to turn these up just a bit. Probably, hopefully. Yeah, because I'm still way louder. That's good. Okay, so here we can have like a tester, right? it inherits from entity, right? Alright. Oh my god, I am so excited. Right. Tester. Here, component. Integer plus this equals 17. Components. Text plus this equals hello PCS. This is absolutely bloody brilliant. Alright. So C++ calling destructor. Usually when it goes out of scope, right? Rarely do you ever need to call the structure. Structure is called when an object is destroyed. For an object like v2 that is local variable, it is destroyed when it goes out of scope. So dynamically allocating using its structure is called when an object is destroyed using delete. If you have a static object, the structure is called when the program terminates. Using delete C++. Using deletes. The delete keyword. Means either using delete operator or delete operator. Okay, delete array. Delete. Okay, cool. Delete pointer. Oh my god, this is. Oh my god. Oh my god. Oh my god. Do I have like a destructor? Do I have things like that? I mean, it'd be nice if I didn't need to, like, updating a thing to, like, destroy a thing would be super dope, right? Because, I mean, like, there's probably ways of dynamically allocating that. Like dynamically updating it for when an entity is destroyed, because destroying entities is super important, right? I really wish I had hand tracking, because my hands would be going absolutely apeshit right now. Oh my god, I can't express just how excited I am for just how well everything is going. Because we have the emitters, then the integers get signature, operator. Okay, cool. Yeah, because as soon as you delete it, it needs to be able to the destructor needs to be able to pull all of the stuff, right? I mean, so I could make things easier for me to use it, but anytime you destroy an entity, there'd be more overhead when you destroy an entity than when you don't, which means that you would have text entity. Do it so. Well, I mean, it'll just be copy text, right? You just do this, right? And everything will be good. And then you can just copy, and then right? And then, oh my god. Like I can't even begin to, like, the amount of excitement is unreal. I did not expect to be able, like, this problem has been absolutely bonkers, dude. Like, it's been, I mean, like, I don't need any of this, I don't need any of this, I can just clean this up a little bit. Like, it is a little bit nuts that, you know, things are, you know, it's not super great, but, like, it's fine, like, it's totally fine. Oh, I am so excited. This is absolutely insane how well this works. Like, it should not be working this well. Like, why is it working this good? Like, is it just that people don't try to innovate? They don't try to simplify? Like, what's... Like, this is undeniably unique compared to every other person that I've seen try and do an entity component system. Like, I have not seen an entity component system work quite the way that this does. Or am I just full of myself? Like, because just like the way this inherently works is very different. Like, there's bits and pieces of things from other stuff. There's like bits and pieces of things from other things, but for the most part, it's completely unique. Am I just a crazy person or something? Like, because I can do like tester A equals new tester yeah, and then I can do system dot or on inits. Let's just try that, right? Let's see if this works. Because if this works, then like I'm dead. Oh no, it didn't work. What's going on? Return testbed header age 105. 105. 105. Cannot convert from T. Cannot convert from T to do. If I do it like that, or I could do, if I do it like that, reference to it. No. Where? Okay. I just do that. What ECS 1700? Both of those are working, so all three of those are doing it. Yeah, all three has to do things. Because they're all doing stuff. Right? Because they all do things. Okay, cool. Perfect. And then I could do deletes A. And then I can do text entity pointer e equals new txt entity. Alright, and I can do system on system on init. Oh god, I hope this works so bad. I hope this works so bad. This should totally, oh my god. Here's the tester text. What's going on here? Oh, what's happening? A should be deleted. Let's see what's going on here. So Hmm. Huh. So none of those have quality enough there. But what's happening here? Let's take a look at text. So, literature. That should not be going. Okay, so another thing that I noticed is that this should actually be 0. This should actually be 1. Something isn't quite working properly. Right? Because text. Because it should be empty. Right? Because all these entities. This is very strange. So A C8 both of these are different. What? Very strange. Okay, so it is being called. Hmm. 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 Interesting. So, what is the system here? So, this is... Check it out. Said... Wait. System signature. Wait. Now why is that have one? Wait a minute. The system signature is 1. And the entity signature is 1. Here's the tester. Only have text. Wait a minute. The system? Oh, that's really bad. It's not and, it's or. This should be that. I mean, I could also do plus. Oh, heck, or. I think that should actually work properly, maybe. But it shouldn't have worked at all. Strange, because now it works perfectly. Well, yeah. So I could do int entity t equals now both of those should do that. Those are two strands, right? Okay. And then Debugging tester. Okay. That is actually what we were expecting. That's why it was working perfectly. Yeah. Yeah. And it just matters on the order in which you do things, so you can have like empty components and things along these lines, right? Okay, so I think I actually have it all proper. Yeah, because instead of supposed to be and, this is supposed to be or, not and. And all these can be done like that. Yeah, I think this literally just works now. Which means that things that I know is that I don't need that. It's pointless. Like I don't need the inheritance. And the only other thing that I need to do is make those expandable. Yeah, I guess I can have the capacity be a thing, and I can say the size instead of count like this. I can just have a size or something. Alright. And then these, because like there are ways of going through special things, but it's not exactly worth it if you ask me. I feel like this is fine. Explicitly, I mean, you could even have certain events occur during the destructor and things like that. So it is a little bit verbose. And I might want to refactor that verbosity to like some degree, but like it should be fine. Yeah, because all of this line works. It just works. Because then I can do delete D and then system on init. And let's take a look here. And I had so much trouble with the old one. I had so much trouble. I had so very much trouble. And this just works. And from what I can understand, this is really efficient too. Alright. Like, this is super efficient. Like, it's perfectly fine. It just works. It just works. It works so well. Like, I don't... Yeah, the only other thing here is just make expandable. I mean, and there are other things too. Like I could make it so that as it, like as you remove more and more and more and more, like it could, like as you remove a bunch, if it gets down to like less than half capacity or something, you could, like it could remove a lot of the unused memory to clean up memory. There's a bunch of other things that I could be doing too to optimize it. But I don't feel like I need to optimize it that much. No, so you just have things like you can say print both system, because it should just work. Like it'll just work. It'll just bloody work. Like it's fine. Like I don't understand it. Like there are a few things. Right, like here. Because like you could return null or something along those lines. Like here, like that's fine. All that is fine. Indices E equals data count. Then you use data push. You set signature to the ID to true, and then you broadcast that change, and then you return information at that location. Basically just do the same thing here too. And you can also push nothing if you wanted to. Like this, the K array is just such a useful data structure. It is such a useful data structure. So useful. So I am going to be using it a lot. Like it's Indian. Everything about this is freaking brilliant, dude. I am blown away that this was able to work this well, this quickly. I mean, as soon as I stopped being an idiot, really. I mean, it's just so simple. Like, there's no reason this should work this well. There really isn't. Like, at all. Oh, that's why, because if it was and. That's why. Okay. So that was proccing on literally everything. Okay. Okay. Let's open. I also need to activate. Oh, there's this to GitHub or GitLab. I think I might actually do GitLab on this one, actually. Because, you know, foxes and all that stuff. Because screw you. That's why. Why wouldn't I use GitLab? I'm a fox. I'm gonna use the fox. Like, come on, man. Come on. If I seriously have to sit down and redo everything, I'm gonna be slightly miffed, not gonna lie. Oh, come on. You know what? I'm gonna do that later. I'll just do that after I'm done. I know, I keep saying that, but you know, screw it. So, guess what's gonna happen? All of this, type diffs. Oh, come on. Come on. All of this stuff. All of these things. All of these things. Oh, bye-bye. So, does scene need a thing? Okay, so init and update and all that stuff is fine, right? So the system can do other things, because I also really need to get stuff drawn. Really need to start drawing stuff. So update in init. Scene. Tester. All this stuff needs to go away. Tester game can stay, but this class needs to go. Because I'm actually not going to have that. Yeah. Class scene 1. Public scene. Public. That's not. How do you spell that? Okay. That's fine. Let's just try and compile and see what happens. Shouldn't have any errors. No? What the hell happened here? What the hell? Oh no. Yeah. Kinda need to delete all these too. Okay. So now it should run. Cool. Perfect. So now that I have that, now I spent 3 hours trying to figure something out, I feel like I can do it all here. And a region, right? So I can also have some other stuff here. I have a pragma region utils, pragma and region. Right. So for one, I know for a fact that I'm going to need to have class, well, it's a templated class. Type T. And this is a class K array. We have the K array. And yeah, I'll still do the data. Oh, I mean it is type T data 1024 for now. And sizing. There'll be another time to go over that. Right. And then it says T head. And I think size T. I don't really want to head or do I really want milestone. I think it's fine. Alright. So then I can have all of this be that, and then I can say come on. Turn head. We can have T reference push. No, actually it would be void. Cheaper average value. Yeah, void push, and then pull. And then it is, well, honestly, I can just copy all of this and just paste it here. Go all the way up in here. And just X V. The system in here is using signature equals std bit set, and this is 1024, and everything else should be fine. Like all of this stuff should just be fine. Like literally all of this should be fine. Like it's so clean. Like how is it? How is it so clean? Like I do not understand how it could be so freaking clean. And even in here, I could just not do this. I could just set that to the scene. The scene update will have it in the scene. In it will have its own things. And just do the system did it. Right? I mean, is system doobly-doo? No. So I could actually delete that. And then static void, I could do I mean, those are static. Actually, no. X B. Yeah, so I can do that. Delete all that. Alright. And also I could do hash pragma region entity component system. I'll just do a hash pragma and region. No, end region. Okay, so the signature changed. I don't really need that. It's cool. And also, I can even have like the scene init do the init list in there. that's fine. Now we get, yeah, that can just be defined as there, it's fine. God, it's so easy. Why was I struggling so hard? There's literally even less crap involved. Like, I seriously don't understand why it was so difficult for me. Like, why did I struggle so hard? Alright. Am I seriously just that much of a retard? Such a dumbass. I'm such a dumbass, I can't even make things easy on myself. Well, to be honest, that does check out. That's pretty much chicken. Signature operator minus. It's freaking. It's like free. It's like free real estate, dude. Like, it's so bloody easy to get all this stuff. Like, it works so goddamn well. Anyone not watching this is missing out. Like, this is brilliant. Like, everyone just missed out on it. That freaking. Oh my god, why is it so good? Okay, game run, game engine, push pop, scene and it. Okay, let's do the do. So, for auto reference, sys and system init list for everything's already done. Everything's already done. Everything's already there. It's all there. It's all good. Everything is there. Everything is awesome. Everything is cool, and you're part of the team. And sys entities. You literally you just do sys sysfn done. You can just do this. This is just a thing that you can do. Why? Why is it so easy? Why is it spicy? Like, I don't need this. I don't need any of this garbage. Like, all this stuff is BS, garbage. Like, it's unnecessary, completely and utterly unnecessary. Like, it's so good. It's so good. Why is it so good? It is so good. It's like I can have multiple different types of, like, just all kinds of different things. Like, I could technically make a game right now you switch between scenes and you do things like an interactive novel. Like, that's a thing that you can do. Like, basically, like right now, it's not even that big of a deal. You just add things to this thing. Like, there are ways to make it a lot easier for people to add in their own components and add in their own systems. I just can't be bothered to actually freaking do it. But like, it's a thing that you could do. Yeah, all this stuff is done at like compile time and everything, but it's fine. Like, I could go into here right now and I can just do class tester public entity. Alright. I can do tester. Right, I mean, technically speaking, I don't need that. I can just do this. I can just say, hey, no components, text plus this equals, here is the awesomeness, and component, integer, plus this equals now 17. You know, and then you do absolutely need to do tester. Then component text minus this component integer minus this. Yeah, like, that's fine. It's fine by me. Like, I don't care. I mean, there. Ooh. I mean, there is potential, because what you can do is sweep through the signature. You can sweep through the signature. Because, like, depending on how long the signature is, how big the signature is, there's like different ways of doing it, right? That's the property stuff. Just depending on the signature, it's iterating over like 1,000 more. Oh, I love you. Because even iterating over 1,000 things is not that big of a deal. Okay. So it is technically possible to go through all of these. Right? Like, it's possible to do. I mean, I'll have to think about that, but you know, I'll have to do better destructor stuff. Alright, I'll have to refactor that. Same thing with like the bit set and stuff like that. With like the signature and all those things. There's better ways of handling this, and I will tackle that. But I mean, just for a thing that functions, like, this is great. Because in here I could do freaking, you know, all kinds of crap. Because in the game 1 syntax in it, yeah, I could do all that stuff. and everything. Fun. I will probably do like a game and all this other kind of stuff, but like it's fine. And there are ways of handling certain things very specifically, like what if you want, you know, things to be more hierarchical in the systems. But, you know, there's other ways of handling that. Like, you can have a specific, you can have a dummy. Like, it's very easy to have things like dummy components to have these kinds of hierarchical things. So, like, it's not that big of a deal. But I really don't like this. You know, it's like generating the signature is something that I don't know. Because again, like I don't want the components to quite be like this. I don't know. I'll have to think about it. Better destructor stuff. Better ID handling. So I think systems is just perfect. Because this is definitely usable. So all of these are things that are just fine. Like they just work just as is. Like this works out of the box. So like I'm not too upset about it. So I can say T. This should compile and run. 2 failed. Why did 2 of them fail? System. Undeclared identifier. What do you mean? And do this pragma and region. This is like the best stream I've had and no one's here to watch it. Sad times. Oh well. It happens. Class. Components, class, system, and that should be all that's necessary. The component is a thing that exists and it's doing its thing, and system init structs, and then the init list, and the system signature changed, and all that should be fine. Good solution. It should be fine. tester class type array definition. Class tester. Because the tester game scene. Yeah. Tester E. And this is tester E, and then this is a tester E. Two player game. Oh, and also this is a tester E player, and this is a new tester E. That's the whole point of it. And then we build solution. One succeeded, one up to date. And then we do the local debugger, and everything should work perfectly fine. Engine initialized, creating scene. Here's the awesomeness. 17. And then both of those. It's a miracle, people. Things are actually working properly. Things are working properly. Things are awesome. I have a fully functioning entity component system. It took me 3 hours to make, and like 2.5 months of headache, of like thinking. Like, it was a colossal pain in the ass. Cool. So I have these things. It functions. It works. It works fine. Again, like I am gonna have to refactor a bunch of shit. Like the ID handling, I don't like. Handling the destructor, I don't like. And I also need to have the K array be, you know, make it expandable. But like, other than that, like, it's fine. Like, it does fine. So, do to do. I know that I have a to do here. And also now I have a to do here. So I have where all the to-dos are located. Let's have where all the to-dos are located. That's perfect. Perfect. Damn, I wasn't expecting this to go quite so well, but I mean, I'm not exactly complaining. The main thing that I need to do, right? You know, and events need to be a thing that I need to figure out. The game class has the stuff that's fine. No. I'll probably I mean, there are ways to actually have to do and stuff like that to search through the things that you need to get done and all that stuff. So like there are things like that, but it's fine. Yay. To do make expandable. Because there are ways of handling that. But I think 1024 is fine. Like, it's whatever. So let's see, pointer. Yeah, because this is technically a pointer of pointers. It's an array of pointers, which in and of itself is a pointer. Yeah. Let's I mean, I could just make this, there are like a few things that I can change for it, but it's fine. Because it can just be a pointer to the engine and stuff like that. So I'm not like reinitializing things a whole bunch of times. Yeah, well, that's fine. So exactly what is it that I need to do now? Details array, K array. I'm just trying to have half hour. Because like memcopy, I could do some memcopy stuff. What's the thing that's the most irritating though? Like the biggest problem I would say is the destructor. And how am I going to do that? Well, the destructor would have to go through each bit. It would have to go through each bit. And it would have to the other option. Alright. The component is kind of like components are kind of really hard coded, which is another thing that I'm not super happy about. Alright. I mean, and I could also reconfigure this to be an index, but the problem with that is that these are all templated, which kind of throws a massive wrench into the problem. Right. The other option is to iterate through the members. Right. That also means getting the signatures a pain in the ass. Right. And technically speaking, like, this is fine, right? But like the biggest thing is that you'd have the ID, and it would be better if the IDs were all inferred, right? But that's also bad because I don't want to have to, figure out a bunch of crap. And having them like this isn't necessarily a bad thing. But that also means having destructor. The destructor is the thing that's going to be kind of a pain in the ass. Alright. So then how do I, because the component struct is like it needs to, because it is a type, right? Like it is a type. I can't just have a naked detemplated kind of thing. So I can't have like an array of just component structs without also having them templated. Right, that's the thing. Like that is the thing that's the problem. Right. Because the only other thing that it could go through all of them manually, right, and have this, you know what I mean? The only other option is, like, say in here I could say if e dot sig dot test at ID if not, do you then return null? Right. Come on. Oh my god, I'm gonna throw my freaking computer out the goddamn window. Yeah. And the only other thing is that I would just have to manually get rid of all that, right? I mean, the ID is a really useful construct. Having the ID is really useful. So I want to have the destructor G and in here to 2 and to 2. Right. Well, actually no, that's over here. The destructor. And what will the destructor do? Here's where things get a little bit tricky, right? And just be component. Actually, you know, I'm gonna write this like for the idiot. Turn over class members. There's got to be a way to do this. There's struct. Macro, but unfold. So there has to be a way. And every time you think of this being the answer you need, you haven't thought things through. The only time I actually needed reflection was when I was capturing struct class features to expose to a Lua table. This is for a project that included exposing functionality, scripting for runtime for to debug though. What options you have? There are various reflection things. You know what? If a game both reflection algorithms opinionated around their middleware, but I do like its options better than Boost. C++ reflection. Okay, let's see here. Okay. So everything has like, yeah, there's a lot of really dumb crap. Yeah. Okay. So C++ does not have reflection, meaning, for the most part, that was basically the best way of doing it. Which I don't like, but like there's a lot of things I don't like about this, but it's fine. Because I could do tester game, and then I can say, tester E. I'm going to do game.run. And then one thing that I could do is I could say T, and then game.run. And this should do things. Hopefully. It should even compile. Oh, it does compile. No compiler errors, that's good. Yes, good. That is the thing that I wanted. So here I should see, here's the awesome, here's the awesome, here's the awesome, 17, 17, here's the awesome, 17, here's the awesome, 17, here's the awesome, 17, here's the awesome, 17, cool. That is working. So all that is working properly, which is perfect. Yeah, all that just works. So unfortunately, however, anytime they want to create a new component, they have to update it. Yeah. Which also means that anytime that I'm doing, you know, particular stuff, like there's a lot of very verbose stuff that I'm not super pleased with. But I feel like it's fine. Now I'm just really impressed that I was able to do such a damn good job today. You know, because I also, like, at this point, all that I need to do, right, since I have the framework, at this point, all that I need to do, well, I guess next is, you know, handle the different types, right? So I have image and scene, right? It's like the scene. Like the game itself is going to have, right? Like the next type is OGL. Right? The next step is the OGL. And setting up the structure for it. And then another thing is that I'm gonna have like scene components. Like that's a thing that I'm gonna need to implement. Right. Because the scene is going to have certain components too. Like the scenes are gonna have to have canvases to some degree. The game is going to have to have, no, I can just do that, I feel like. Because here I can just do that. This should work. This should compile and run. There might be some kind of, oh, there is no compiler. That's good. Initially, just creating a scene. Cool. That's perfect. Yeah, this is just cleaner. I'm blown away at how well this shit works. Because each level of the game can be a new scene. And like a bunch of different shit like that, right? And you can even have yeah, there's like a bunch of different things. You can have like a master scene that doesn't render anything. That doesn't have, you know, things that's just a container for certain, you know, entities and things like that. Which I think would be really cool. So yeah, I fully managed to grab out an empty component system in 4 hours. It's so good! Like, it's practically perfect. Like, it's so goddamn good. It's so good. Like, it's just clean and simple. Like, the old one was just all over the damn place. Here we just have a handful of ideas, just a handful of things. You know, and each one is just in control of whatever it is that it needs to do. And it's just super easy to use, super simple to use. You know, like it's a little bit verbose at times, but it's not that bad. Like the hardest part is just new components and like new systems. But even that isn't that big of a deal. Like it's really not that big of a deal. They just have to put it in one place and they can just delete all these and it doesn't care. Same thing with all these, like it doesn't matter. Because everything is just right there. Like it's all just fine and it all just works so bloody well together. You know, I feel like a bit set of 1024 is a bit much, but you know, I mean it is what it is. Yeah. Oh wait, hold on. Hold up. I think, technically speaking, because of what I should actually be doing. Maybe instead of this being a signature, what I should actually be doing is returning a signature. Yeah, it should be a signature. So this should actually return a signature. Get saved. Okay. So sure S. Okay, S dot set be true. Return S. Should be fine. So I should be able to say here's components. integer get sig. And then here is component. I'll do that. Components, text, get signature, or component, integer, get signature. And it should be fine because this will combine the two together. Yay. Perfect. I mean, I guess I could also have one that's like a make signature. It might actually be better. Make signature and just pass in, but so I don't have to use the get signature thing. It just returns the ID. I think I'm gonna do that. That seems a little bit better. System public. And then this is and this is a size T. Wait. Let's see if that's a thing I can do. C++ bit set initialize with particular bit set. How many different things? Given decimal number in binary form. Copy signature to clipboard. Return signature. Not set. Return signature set ID. Come on. Come on. No. So that's the thing. Return signature set ID. What? Should be a thing. So I can do make signature component .id. Oh. Okay. That's German. Yeah, this is just better. Next signature. Component. Register.id. Copy. Make signature component text. Perfect. Yeah, I think I like that better. Yeah, I think I like this better. Just a little bit of refactoring to help out the homies. I still don't care about the ID handling. ID handling is still bad. The entity, that's all done. So that's completely finished. Component struct. Yeah. Yeah, init struct. So really the next part is going to be drawing shit to screen. The canvas element. That's gonna be fun. I also don't care about namespace details because I'm not going to be using that. I'm just going to be doing one header file. One header file, one .lib. And then that'll be it. So I'm very pleased with how much I got done this stream. I feel like a lot of the stuff that I'm going to be doing, I am going to be using the test bed a lot more. Alright. So I got a lot done, like empty component and systems. That's all that there is. Concept of signatures. Yeah, bunch of stuff to do with those and components, which are in essence super simple. There's really not much to them. We have a struct with, you know, a couple of helper functions, some overloads and stuff. But it really just has an unordered map of indices, the data, and its ID. Like, that's it. That's all that's to a component. Which that really is all that needs to happen to a component. An entity just holds a signature and has, you know, a destructor. Which again, that's all that should be happening. And the, you know, systems is you have a helper function to make signatures. Which you don't need for entities. because it does it automatically as you add components. And yeah, because you have component strings and all that. Oh, it's so gorgeous. It's beautiful. And then here you just have, you know, your instructs. Wait, you need that? I don't. Because it's all implied. Because it's all implied. Okay. Oh, that's even better. God, I can be so damn lazy. This is great. I love every part of this. I really do. Wait a minute. Would there be a way to... Well, I mean, the only other way is that you'd have some kind of registration, right? Or you'd have reflection. Those are the only two ways that you could pull it off. I really don't want to use boost. And NTT, it has reflection. I'd have to, I don't know. Like, this does make things a little bit strange, but this also clearly indicates that the systems are hidden. You know what I mean? Like, it makes it very clear that you do not actually directly handle each system. They don't really exist. They're very nebulous constructs. They're nebulous constructs. So that is a thing to keep in mind. I feel like I should probably... Yeah. Swap the order of this. And the reason why I should swap the order is because this makes it seem like you're like declaring. This makes it kind of feel like you're declaring the typing. In essence, you're, you know, declaring the typing and stuff like that. So this just makes things a lot easier to handle. And the last thing is just the entity set, and that's implicit. That's implied. So it doesn't need to be put in there. It's unnecessary. So that way you can say make signature, do that, make signature, do that. Yeah, you do need to do the make signature. Because the signature is just a type def, effectively, it's just a bit set. And I don't necessarily want to create that, make that as a... There's just certain things that you don't really need. It's the only other option, is just to make a signature for each of these. Each of these gets a signature, but that's excessive. And quite frankly, just a little bad. And it's not necessary. Like, yeah, this is a bit excessive. It's very large, but it's fine. And there are just a few more things that I need to change, and then it'll be perfect. Why is this so good? Damn, I'm good. Sometimes, eventually. And that's the thing, that if you're walled by something, just take a breather, get something close to it so you can better understand the problem, and then work from there. And it's literally all that I did. I made a functioning, pseudo-functioning NGD component system, and figured out exactly how it works, and what it is that I liked about it, and what it is that I didn't like about it, and then went from there. Alright. Yeah. And all these things are... This will make a lot of sense, so that I can have, you know, all of these things happen, and do the stuff that I wanted to do. Alright, well, it's been 4 hours. Basically nobody watched. Oh, I have 2 viewers. Cool. Now I have 2 people watching. I'm sorry, but you've pretty much gotten to the end. Yeah. So this is going to be the end of the stream. I'm going to end it here. Thank you guys for watching. I still need to actually make everything go public on YouTube and fix all that crap too. But I will end it here. So thank you guys for sticking around and watching me